So this video I will teach you what is inside this RT 220 volt, 120 to 240 volt, 5 volt output, 4.5 ampere cell phone trickle charger, which is a fast charger. Now open this part like that. This part is too like there. Something let me this that way. Now it's pop off like that, and there's the back side label. And I realize there are 3 little dots. So I think there are screws, but there's no screws. There's just a molding to that. Two pieces are molding to that. So what I can do? We need to open this by peeling the sticker back side. So this is a charger. It is come with separate. The older you can plug any lead according to your which sticker you live or which you are using. Now accidentally sticker is quite hard. I peel out, and there is a transformer, copper transformer looting, and there is looting the capacitor and LED. Now in order to open this, we need to break this charger apart, because I realize these screws are not a screws. So we need to only way in order to open this, break the charger. So this is a metal bracket. So this is a metal design bracket, which is not maybe come out or not. Let's try one more good. Okay, so I realize this is not easy to open. So what we can do, we can put a screwdriver over here and little bit straight like that, or we just break a part. I think we need a better part of the charger, because it is a whole broken charger. So I did not need this charger, because this charger is not working due to this charger accidentally fall out in my hand, and bottom it's due to a floor, and it breaks internally. Now I'm cut this. So basically I try overforce is a hard plastic. So the only final way to open this, we need to use a knife and touch this off, and right now it is open light somewhere like that. So this is a very hard plastic. Before starting video, I was thinking it is very easy to open, but it is not easy to open. It is very difficult. Now this is a circuit board, and this is a genuine charger. Now put our board apart out to this unit. Maybe up right. Both are there are a lot together with some these lots. In order to move the board, you can carefully to the tolerance. So both will unlock and come out to the unit itself. So this is a basically this board charger's fault is that this charger can fall down with my hand, and it will blow. Let me there are 1 to 2 I think which need to open them, and then in order to remove this. So this charges fall down in my hand. So that's why it is brought internally break, and there's no burnt out. So right now I open it, I cannot see anything inside break. Right now further open and see what is inside. What is inside board. And there's problem with that if you use a multiple screw, there's quite a confusing which screw is right to open with doors. These are quite the screws, which is little bit difficult. to identify which screw is which. So there is one screw. This screw over the PCB, and once this screw, this is the right screw, and this bore is this screw come out, and bore is off. Now this is both front side. There is no anything breaking like at the notch. Anything is break over both the sides. There is a fuse, which is basically R1 resistor, and there is a rectified back. And there is a capacitor, and there is a bias capacitor, and there is a biasing diode. There is a driver IC with couple of resistors, 4 resistors for transaction, and there is a number network diode and a number network capacitor, transformer, output jack, class wide capacitor, class wide capacitor, and there is output filter capacitor and regulator for regulation output current. There it is, and now it's time to do engineering and then continue with need. And once pause. There is no isolation between primary and secondary. So you can see this is a primary portion over here and secondary portion over here. And this LED is connected to the secondary side, and this LED is placed in the primary section. So there is an easy rift starting between primary and secondary, and this chance to acceleration to the output your phone till your phone, because there is no isolation, the isolation between primary and secondary, and primary wire side little bit voltage increasing, and then spark is created and they jump in the secondary and damage your phone. Make sure your phone charger internal circuit board have a galvanic isolation between primary and secondary side, which charger is almost good. If your charger have primary and secondary side is no isolation between galvanic isolation between, there is not a good charger, and this is local. Once pause. Live dose fuse with 0.33 ohm resistor, local base rectifier directly to the rectifier, and negative dose output rectifier, negative dose 10 microfarad 400 volt capacitor. Accidentally I put up 40 volt. I change it. Right now I have at one point. So it's to 400 volt capacitor. Then negative also goes to 10 microfarad 50 volt capacitor negative, which is a bias capacitor, and main 300 volt DC positive is goes to the 400 volt 10 microfarad capacitor positive will drop down, and 2 ohm resistor, and then those 50 volt 10 microfarad capacitor positive. And there are IC needs. Pin number 1 is I have positive voltage with 9 ohm resistor. This 9 ohm resistor is a total limited resistance between the positive to the IC pin number 1. IC 2 or 3 common together, and IC pin number 4 is a feedback pin, which pin is connected this capacitor positive, which is 10 microfarad 50 volt capacitor. And IC needs negative terminal common ground, which is supplied by pin number 5 pin of the IC to the negative HV I side ground, and pin number 6, 7 are drain, which is common together and connected to the primary winding, and primary winding other terminal is connected positive, and feedback winding one terminal is connected ground, other terminal is connected diode to the this 10 microfarad 50 volt capacitor. First voltage dose AC in rectified, then smooth DC, filter it, and then filter voltage goes to the IC with the help of filter voltage goes to a transformer, one terminal to transformer, other terminal switch by IC to the transformer, other terminal and transformer generate self-induction, which induction is discharged by this A7 diode plus 102 120v semi-capacitor with 200 kilo resistor as a snubble network, and this magnetic field is collapsed to a transformer. It's picked up by secondary winding as well as feedback winding. So feedback winding generate voltage, which produce voltage around 12 volt, which then goes to A7 to rectify and charge this capacitor which is feeding the power to this IC to continuously run on. But when there's no power, first then plus there's no power in this point, there's no switching, and this cannot give a feedback voltage into the IC. So first we need a self-start. It will trigger our self-start in order to generate our voltage step down. So this IC data a feedback, a startup voltage by this 2 megaohm resistor to the 300 volt. So once this IC is done, it automatically shifts its own power via this diode and this feedback winding, and this capacitors provide without pure voltage, without any fluctuation, and this main filter capacitor. And there is a transient resistor. This resistor, if you change this resistor, there is a fast charge. If number of low resistance, resistor is increasing, the charger charging more faster. If resistor is decreasing by this resistor, charging is slower. And this side is a secondary one terminal door to exactly output other terminals door that is regulator which is on with the diode. Rectifier also regulate, and then those 10 microfarad 10 volt capacitor to smooth and discharge by 1 kilo ohm resistor acts like the load to the little bit load for voltage fluctuation, as so also discharge is capacitor. So if any condition someone kindle it is not damaged, letting electric short. And these is also those two USB port in parallel, as well as LED which is driven by 2 kilo ohm resistor in order to indicate power is present or not. So this regulator number is 8306. I cannot find a sheet about this regulator, and if you have STIC which is HH3611, I cannot also find any data sheet about these two components. These are mystery components, and these little circuit is. And this video can be the next video I can pause.